Hello, today we're starting Chapter 4. Chapter 4 is quite a big chapter and it deals with quadratics. Quadratic graphs will always look like a U, which is known as a parabola. And then a quadratic will always have the highest term have an exponent of 2. One way we can graph is always do an XY chart. This may not be the quickest way for a lot of these, but for this, it's fairly easy. So if I'd plug negative 2 squared in, negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Now if you notice, there's a pattern here. I started at 4, went down to 1, went to 0. Then I'm going back up to 1 and back up to 4. My lowest point is my vertex. It also could be my highest point. So now I plot these points. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now this parabola, it should look like a U. And if you notice, I put arrows going up because they keep going on forever and ever. Now there's 3 forms for quadratics. The first form that we'll go over today is called standard form. And it looks like this. Y equals ax squared plus bx plus c. We can relate a lot of this back to when we were graphing absolute values. Okay? If a is positive, then our parabola will open up. If a is negative, our parabola will open down. Also, if a, we don't look at the sign, but if it is larger than 1, then our parabola is narrower. So it's going to shrink. It's going to be closer to the y-axis. Okay? Then if it is smaller than 1, it'll be wider, so it stretches out. And then if it is 1, it'll just be the same. Okay, it's neither wide nor narrow. So let's look at these next ones. So this is A, B, C. Now we look at A to tell us if it opens up or down. Here it's negative, so it opens down. Okay, now we look at the 2. So 2 is bigger than 1, so it's narrower. If we look at the next one, look at A, B, and C. You'll notice that I will label these every single time. That's the first thing I do. A is positive, so it opens up. 1/2 is smaller than 1, so it's wider. Now, standard form, ax squared plus bx plus c, we need to find the vertex. Remember, vertex is always x, y. So to do that, to find my x, I will use this little formula, negative b over 2a. That gives me my x for my vertex. To find my y, I would just plug x into the original equation. Okay? The x of our vertex is also known as our axis of symmetry. If you look over here, the green line, axis of symmetry, that's where it cuts our parabola directly in half. So your x and your x of your vertex and your axis of symmetry will be the exact same number every single time. Now we can look at these equations to identify a minimum or a maximum. Minimum means it's the lowest point of our graph. Maximum means our vertex is the highest point. So now, look at this. Which way does this graph open? Look at A. A is negative, so it's going to open down. Now this isn't the exact graph, it's just an example. It opens down, so our vertex would be up here. That is the highest point. So that means the highest is the maximum. With this one, A, B, and C, A is positive, so it opens up. Now remember, this is just an example graph. So my vertex would be down here. That's the lowest point. So that would be the minimum. Okay? So if it opens up, it will be a minimum. If it opens down, it will be a maximum. So now let's find the vertex and line of symmetry. So the first thing I'm going to do is label it A, B, and C. So I use that formula, x equals negative b over 2a to find my x. So b is negative 18. So negative, negative 18. Two negatives make a positive here. All over 2 times a. A is 3. So I have 18. 2 times 3 is 6. So 18 divided by 6 is 3. So my x of my vertex is 3. That is also my axis of symmetry. Now to find my y, I take whatever I get for x and I plug it back into that original equation. So I'm going to go and replace x with 3 in that original equation. So you can use a calculator or use order of operations. When you do this, you will find your your y to be negative 7. So there's my vertex, 3, negative 7. And remember, your axis or your line of symmetry is always the same as your x of your vertex. 3, 3. So now I'll do the same exact thing. First thing, label A, B, and C. So to find my x of my vertex, I use negative b over 2a. So negative, b is positive 8, so it's going to be negative 8 all over 2 times a. A is negative 1/2. So I have negative 8 all over, well, half of 2 is 1, and it's going to be negative. So it'd be positive 8. So of my vertex, I have my x, which is 8, and now I have my axis of symmetry. Now I just need to find my y. So I take whatever I got for x, which is 8, and I plug it into that original equation. And if you want, you can plug it into the calculator exactly how I'm writing it. Okay? Put those parentheses, those are important, because calculators are designed to do everything in the order of operations. When I do that, I get 27. So my vertex of this quadratic would be 827, and I'd have this axis of symmetry, this line going up and down through my vertex at 8. Now we've used A and B to find the vertex and axis of symmetry. The C, that is our y-intercept. That's very important. That'll be the next thing that we use to be able to graph. So if we look, this is 1, it's where our graph crosses the y-axis, so it's 1. So that would be our C. So that last number, that C, is always your y-intercept. So A, if I label these A, B, and C, C equals 6. That would be our y-intercept. Label these A, B, and C. C equals negative 1. That would be our y-intercept. That's where our graph crosses the y-intercept. This next slide just deals with, just goes to show minimum and maximum. Remember, minimum is the lowest point. Maximum is the highest point. Okay? Your vertex is the highest point. Minimum is your vertex is the lowest point that it could be. Alright, now let's throw everything together. The first thing I'm going to do to graph a quadratic in standard form is label my numbers A, B, and C. Next, I'm going to use that negative b over 2a to find my x of my vertex. So negative, b is 6, all over 2 times a. A is negative 1. So I have negative 6 over negative 2, which is positive 3. So now my vertex, I have 3 for my x. That is also my axis of symmetry. Remember, these are the same. Now to find my y, I'll just take 3 and I plug it in to that original equation. So every place there's a x, I plug in 3. When I do that, I'd find my y to be 7. So now, I can go and plot that. 3, 7. So 3, well, there's not enough room, so 6, 7. 3, 7 is up here. I'm going to draw a dashed line for my axis of symmetry going directly up and down. Okay? So here's my vertex. Now, C, remember C is our y-intercept. So I go to my y-axis at negative 2 and plot a point. Now my reflection point. My reflection point is going to be, if I look, everything on the left side of the axis of symmetry should be the same as everything on the right. So look at this point. It is 1, 2, 3 points away from your axis of symmetry. So I need to go 3 points away on the other side of my dashed line. I know I don't have a lot of room, so I'll just put it right here, but think about it, it should be 3 points away. Now I can graph that, so I just connect them. Okay, remember that should be 3 points away, and I should move that so it is on my graph. My reflection point, 3 points away, would be 1, 2, 3. So it would be 6, negative 2. Last but not least, determine a minimum or maximum. Minimum means it's the lowest point, maximum is the highest point. Well, this opens down, so it's going to be a maximum. Okay. So now let's try that last one. First thing, label A, B, and C. Vertex, to find my x, I use negative b over 2a. So negative, b is negative 2. So 2 negatives here make a positive. All over 2 times a, which is 1/2. So half of 2 is 1, so my x is 2. So of my vertex I have 2, and that is also my axis of symmetry. Now to find my y, I just plug 2 in for x. When I do that, I should get negative 1. So now I can plot that. 2, negative 1 is my vertex. So x is 2, y is negative 1. Draw my axis of symmetry, that dashed line going straight up and down. Remember, your c, back in your original equation, is your y-intercept. So c equals 1. So I go to my y-axis at 1, plot a point. Now my reflection point is, if you see, your y-intercept is 2 points away from your dashed line on the left side, so it has to be 2 points away on the right side. I can draw my parabola. So my reflection point, this point right here would be 4, 1. It opens up, so it is a minimum. Okay. Alright, so now try the practice page. It's very similar to what we did here at the last 2 problems. Remember, you can always stop, pause this video at times if you want to, catch up. Remember, I only have 15 minutes for this video that I can put on at one time, and I try to get everything done. So it may go a little fast, but you can always pause it. Okay. So if you have questions, just let me know. Okay. Email me or ask me in class. Have a good day.